Hey everybody, this is Alex Merced from alexmercedcoder.com, and this is my first video in learning the programming language Rust. While I do have the Rust compiler installed on my computer, I figured it would be easier to just show you guys by using REPL.it. So you can easily go open up an account for free at REPL.it and use this to kind of practice programming in Rust. Okay, and like a lot of other compiled languages, it all starts with a function definition for a function called main. And the compiler just takes that main function as sort of the starting point of the program. And that's generally how all these compiled languages work, whether we're talking about C, C++, Go, Java, you always start with the main function. And always the first thing you want to learn is the function for printing stuff to the console, which is print line with an exclamation point. Okay, which means it's a macro. Anytime you see that exclamation point at the end of a function name, it's called a macro, and it's just a pre-built thing. Okay, in this particular case. So if I do this, if I run this, it's going to compile and eventually do the thing. Hello world. Now the reason why Rust is cool, one, Rust is made by Mozilla, the Firefox people, but Rust tries to be sort of a low-level systems language like C or C++. Okay, one of the nice things about Ruby, Python, those interpreted languages, they do what's called this garbage collection. So every time that a variable is no longer, or a piece of data is no longer being referenced, it goes in and cleans that up out of the memory. So this way you're not overusing memory. The problem is the garbage collector is a process in itself which slows down things. Okay, so if they're doing a lot of garbage collection because there's a lot of data going in and out, it can slow down the program to be doing that frequent garbage collection. Okay, in C and C++ and Java and some of the other lower level languages, the garbage collections are left a little bit more manual. You get to kind of decide when do we go back and clean the memory, or do it manually. But it can be quite painful to do it in C and C++. Okay, so Rust tries to meet you in the middle where it doesn't have automatic garbage collection, but you can trigger points where there's garbage collection. So you can get the convenience of, hey, look for, see what we can get rid of, but you get to decide when it happens without having to sit there and manually kind of do it. Okay, so it gives you that sort of very low level control over what your program does, which makes the program much faster than if you did in like Python, Ruby, or JavaScript. So it gives you the speed of C++ without without as painful memory management. That's sort of the selling point of Rust. But basic things in Rust is that by default variables are immutable. So if I were to do this, if I were to sit there and say let, so they use the let keyword to create a variable, let my int, okay, which I can choose not to, but I can also type it and just say, hey, I want it to be an int. That makes it explicit that it is going to be an integer, and do that. If otherwise, it would dynamically interpret it. So if I just did my int equals 5, it'll just like, oh, well, 5 is an integer, so we're going to assume this is an int. And the benefit of being explicit with typing always is you catch errors. Because what if I did this, 5.5? Okay, that's going to throw an error because 5.5 is not an integer, it's a float. So let's see. Not found in the scope. Cannot find type int in the scope. Here's error. Yeah, it's supposed to be integer. Actually, let me change this back to 5, see if that fixes it. No. Let's go back over here. Data types. That I make a mistake on what an integer is referred to as. 2. I see. They use these abbreviations, so that technically what I would want to do is, oh, no, not there. Oh, going back to that Ruby stuff. What I want to do is that the type is not called that, it's called I32, meaning a 32-bit integer. Okay, and then if I did this, 5.5, see, now it's going to give me an error because it found the floating point number instead of the type I specified. So that's the benefit of being explicit. Now, if I don't do that, okay, let's see what it says. My int, hopefully this is an intentional prefix, it with an underscore, unused variable. Oh, just because I didn't use the variable. That's what it's complaining about. But let's print the variable my int, so that way it doesn't complain that it wasn't used. My int. Okay, format argument must be a string literal. You might be missing a string literal to format with. Okay, so what it wants me to do is this. So this is kind of like C++, where you have to kind of put the string first and then pass in the data pieces you want to fill. So essentially what this is going to do is that this is a string, and I can just be like my int has the value of, and then right here where the first curly brackets are is where it's going to interject this value as a string. So okay, okay, that's just a warning. My int, did I spell it wrong? My int. Let my int they want me to by force to have a snake case name. It's interesting that they're actually enforcing that. Okay, that looks good. It's compiling. And there you go. See, my int has the value 5.5. So since I didn't put the explicit type here, it just allowed that float to be there. So the benefit of typing is to make sure that you don't actually assign values you didn't mean to assign to a variable. So I really wanted it to be 5. Okay, we got to learn all the different types. But again, you don't have to. You don't have to sit there and memorize all the types. If you don't want to, you can allow there to be dynamic assignments. But the other thing to keep in mind is that when you assign a variable, it's by default, it's constant. So if I were to sit there and afterwards do my int equals 6, I'm going to get an error. I got to put a semicolon. So you can't assign twice. By default, it's immutable, meaning you can't change it. So if I want it to be mutable, I have to add this to the definition. Let mute, meaning let it be mutable, my int equals 5. Now this should work. Okay, well, instead I triggered some other warning value assigned to my int is never read. Okay, so they're just talking about that the 5 is never used. So what I'm going to do is this. This compiler's pretty... Well, I do like the warnings, though. The warnings are actually fairly informative. Okay. And there you go. So you see, since now I used it, I used the value of 5, and then I change it, and then I use it, it doesn't give me that warning anymore. So this way I don't have, like, unused values hanging around. Because the idea is that they would prefer that I leave my data as immutable. So instead of, if I'm going to be reassigning it and not using things, it would have been better off for me to just not have had the first 5 in there, or something like that. Okay, so that is cool. Yeah, so that's sort of the basics. So we've learned how to assign date variables and the typing of it. Learned a little bit about printing strings, and we've learned about how to do interpolation this way. Okay, that's pretty good first lesson. Then we'll get into like how arrays and data structures work and control flow in the coming videos. So I'll see you guys later on. Have a good one.